Hello guys, welcome back to class. In this session, we'll see the module 2 of Pandas. We'll explore about how to create data frames, what are the attributes and important descriptive methods, and how to select the rows and columns, what are the basic syntaxes. If you want to modify the data frame, like you want to add a column or you want to drop the column, you want to add a row, you want to drop the row, this kind of modifications to the already created data frame. Then transposing, generally no use of transposing, but yes, you can do it. Importantly, sorting and resetting indexes. These key topics will start in this session. So let's start with creating data frames. As we understand in the previous session, data frame is like a table, right? Data frame is like a table. It contains rows and columns with the labels, rows and columns with the labels, and supports variety of data types. Variety of data types means your columns can be of different types. Suppose if you take customer ID, maybe of number type, customer name, string type, customer DOB, maybe a date type, right? What else? Maybe customer balance, double or floating type. So all types of data types supported by this columns. So you can create data frame from variety of sources. From dictionary, you can create, if you have a series, you can create a list or a tuples. From another data frame, you can create or reading. So from this, most commonly used are, first always we'll use the files, right? Whenever we work on the real world projects, we always read data from either CSV file or Excel file or JSON file. JSON file I'll show you. Today example I'll show you. JSON, etc. Okay. And when you do practice or when you write a sample piece of code and all, we'll prefer to use dictionary only. Easy way to write it, but there are ways. You can also use other options. Let's explore all the ways to create the data frame. So already from dictionary we have seen previously. So I have a simple dictionary. This is a symbol of dictionary, right? We have seen many times, which has keys and values. Key is a simple string name. Value is list of names. Age, list of ages. Course, list of courses. So I have a data frame. I have a dictionary. The name I'm taking as a my data. Then you can create data frame using PD. That's what alias of Pandas library, which we imported. PD dot data frame. D capital, F capital. Remember that. And what I have to pass? Pass the my data. Here there is an attribute actually to show that I changed it. Data equals to, you specify. Data is an attribute of data frame constructor, so that whatever you write, you are assigning that. Default is that only. So we are not specifying generally this. Without this also, we can specify it, right? So with this also we can. Let's run this. So we have 3 records, right? Name is one column, all the name values in a list. Age, another column, all the age values in a list. Course, another column, all the course values. Every row has an index starting from 0, 1, 2, right? We prefer not printing DF so that it will be easy for us. It means the look and feel will be different. Just same thing only, tabular format, you have better look and feel when you directly do this printing DF. without print method. Okay. So that's how you do with a dictionary. Second option, with the Pandas series. With the Pandas series, when you create a series, here is a difference. You see small difference. When you take name in the dictionary, name is the key. Values are all the names only. Values are all the names only. Age, all the age values. Course, all the course values. But in the case of series, when you create, you see the series you're creating. I'm intentionally using my data. So here, just make a separator for this. When you create a series object, see what is this? Second option we are using list of series objects, right? So you create a series object like this, one series object, comma, second series object, comma, third series object. When you're creating series object, it contains the list of a record actually, the name, age, and the course. Second series object, constructor you're passing the list, name, age, course, and third. We won't use unnecessary of creating series. Anyway, it will create internally series objects, right? We don't need to worry about. There is a syntax something like this. So you can create like this. And here if you see, first time when I create data frame, I'm creating from a series, right? Any column name specified in this, guys? Are you seeing any column names? Are you seeing any column names in this? No, right? We don't have any column names. See how the column names came. Column names also 0. You can call as column indexes, even column labels. Here 0 is the index. You can call this as index or maybe the label also. Anything, both. Column wise. Same row wise also. These are either you call as a row indexes or the row labels. Some number indexing or number labels. Similarly, column also you have taken as 0, 1, 2. Fine. 0, 1, 2. I think no need to create another data frame again. So after that, I am setting the columns now. df dot columns equals to, you specify the column names so that the default labeling 0, 1, 2 or default column names 0, 1, 2 will be replaced with column names whatever you set. df dot columns equals to, you specify the list of columns you have and make sure that how many columns you have in the data phrase. You can't do more. For example, if I take it as something A, additionally I am using one thing. Additionally you can't do. So it should be the length mismatch. Expected access has 3 elements, but new values have 4 elements. You cannot do this, 3. But can I do 2 only? Can I do 2 columns? Guess. So expected has 3 elements, but values you have only 2. You have to pass always the number of columns you have in this. Okay, 3. Okay. So here only output you see. Output you see here. See, we created a series object, guys. So this is one series object. This is one record, right? This is one record. Name, age, and course. This you are passing for a series. Created a one series object. Second series object, comma, star series object. Like this, you can create a list of series objects you're defining first. Previously, we defined a dictionary. My data is a dictionary variable holding a dictionary object. Here, my data contains list of series objects. With the series objects, we're creating a data frame. When you create data frame first time with the series objects, it's creating a data frame with the respective names, ages, and courses. But only thing is, we don't have a column names here. That's what columns taken as 0, 1, 2. Is this clear? Columns taken as 0, 1, 2. Now, I am saying I don't want this. I want a readable column names. Simple attribute is the columns is an attribute of data frame. This is not a method, right? Because I am using df dot columns. If I use the parenthesis like this, then it is a method. I'm not using parenthesis, so it is a attribute. For this, you specify the list of columns. How many columns you have? How many columns? This is a labeling, yes. This is also labeling. Column names are labeling. Whatever label you are specifying this here. Now 0, 1, 2, 3 replaced with C, name, age, and codes. Okay. In the dictionary, this extra work is not required because whatever the dictionary keys you written, name, age, codes, automatically taken as fine. Generally, we won't use this list of series, might be just have a syntax like this. List of list, this is more easy than list of series objects, guys. See, we have with the list of this, you're creating a series unnecessarily, right? But easiest way is you specify list of list. This is a top level list. This is the first list, contain one record. Second list containing second record. Third list containing another record. Okay. Fine. Now, this is a constructor. Look, in any case, if you want to create a data frame, you're creating data frame with the constructor. Here also, data frame of data is a variable of the data frame class. You are assigning your variable called my data. Here, I didn't write data equals to because whatever you pass, by default, it will go to data variable only. So it is an optional. Still, if you want to write, you can write unnecessary. Understand, Alok? Next, we have a list. So I'm creating a list equals to my data equals to list of list. You can also pass here only columns, guys. Separately, you can set as a columns. See, here only you see that. Where my data going, you write clearly otherwise. Data equals to my data, that is the list of list. Columns equals to name, code, age, and codes. You can also say the columns separately like df columns, or maybe here only you can pass the column attributes. So constructor, we are passing two arguments here. First argument is data. Where is your data? You are creating data frame. Data frame needs the data. Where is the data? Where data is in a my data list, which is a list of lists. And columns equals to whatever column names you want, you specify the columns. Is this clear? List of lists clear? Dictionary we use always. Easy, right? Dictionary is again no need to set any columns. Dictionary keys will go as columns automatically. Okay. Another data frame. Row labels also, yes, we can use. I'll show you that, Purushottam. Column labels I am showing now. Row labels also I'll show you. We have that examples also. So another data frame. I have a data in dictionary. My data equals to some dictionary I have. Okay. Then you create data frame df1, pd dot data frame of my data. df1 is created. Data frame is created from the dictionary, right? So print the df1. Next, I am creating data frame constructor again by passing data frame constructor by passing data frame object as parameter. You see this data frame as parameter. So df2 created using the constructor which is taking df1. df1 already having data, right? So that only we are passing here. df2 created. Another way is there is a copy method df1 dot copy. df1 dot copy. This also makes a data frame based on another data frame. These two lines are clear. So df2 and df3 I am creating. How I am creating df2, guys? df2 I am creating based on existing data frame only using the constructor. So this I am creating data frame from another data frame using constructor. And here I am creating a new data frame df3 based on existing data from df1 using copy method. But when you create using the constructor, this makes the shallow copy and this makes the deep copy. I think you know the shallow copy and deep copy, right? Yeah, data frame constructor is overloaded. It takes so many parameters. Important parameters. As of now, you tell me how many parameters we discussed. Data frame constructor, you are asking, all of you are sitting in the data frame constructor. Okay. You tell me, guys, as of now, how many parameters of data frame constructor are discussed till now? Tell me that. 2. Very good. One is the data, second is the columns. Data and columns. So what can be the data? Data you can pass as a dictionary. Suppose here also you see, guys, data equals to df1. What I am saying, data equals to df1. So what can be assigned to the data parameter? You tell me what options I have for data parameter. As of now, as of our discussion. For data parameter, we can pass a dictionary, we can pass a list of series, we can pass a list of list, we can pass a list of tuple. I didn't show you the example of tuple, but you can write list of tuple. You can write another data frame as a parameter, right? Another data frame as a parameter. So in this example, what I am passing is, I am passing data frame as a parameter. Data equals to df1. Data frame as a parameter. Based on this existing data frame, it is going to create. So this difference is clear between the creating data frame from another data frame using the constructor, using the copy method. Copy method makes a deep copy and data frame constructor takes the shallow copy. What is the difference between deep copy and shallow copy? Difference between deep copy and shallow copy, guys. Shallow copy means, oh, some are telling reverse, guys. Shallow copy means address of existing object will be assigned to df2. It means here when you create df2, Yes, yes. Some of you guys right. I am creating df2 based on df1, correct? It is making a shallow copy. Means in the case of df2, which is making shallow copy, it is not creating the data from object internally, again a separate object. It's not creating a separate object. It is just taking the address only. It means if I change data frame 1, will it impact the data frame 2? Can access the modifications in data frame 2? Yes, that's a shallow. And df3, I'm creating from df2 using the copy method. This makes the new object, brand new object will be created. There's no relation between df1 and df3. df3 is getting its own object. df3 is getting its own object. Now, when you modify df1, it won't impact the df3 because it has its own brand new object. Clear? So data remains the same. The key points here you see, pd.dataFrame of df1. If you use this line creates the shallow copy, and df1.copy creates a deep copy. If you change a value in df1, df2 may reflect it since it is a shallow copy. df3 will not be affected because df3 has its own copy because of deep copy. Fine. Next. Most important option, you can read from the files. It may be a CSV file, it may be an Excel file, it may be a JSON file. Simple, you keep your file in the respective format and the correct format. It may be a CSV, okay, student data or JSON or something. The method, there are variety of methods. Read underscore CSV to read from CSV. Read underscore CSV, pass a CSV file name. Read underscore Excel, read underscore JSON. 3 different. We should have these files, right? We should have these files. Let me take this. I have one folder called datasets. I'll keep this datasets folder in your wait. I'm just importing this, guys. Upload it. Where is one more file? My students.excel CSV JSON. So file name change it to my students. Okay. Make sure that the formats are correct, guys. CSV, the format is neat. While parsing, internally they have written a code. You know, I think how to read from a CSV file or JSON file might be written in your projects previously using Java or whatever you learned. But here all that they are written using Python. We call a simple method. Any variable it prints like this, not only df1, I think we discussed at the beginning. Single variable you can print in the, this is only the feature of the, this is only the feature of collab, guys. You can't do this in a outside the world, right? Only collab, in a one collab, you can run only, you can print only one cell, one only, one cell, one command, you can print it. Okay, let's run this command. So reading data from CSV file, 7 records, same data I have in all. Reading data from Excel file, Done. Reading data from JSON file. Done. IO operation is different. Immutable for you. You have a simple methods. You just call it internally, they do whatever required and they'll bring you the data back. Is this clear, guys? So we understand how to create data frame. Let's quickly revise all this. Okay. So from this creating data frame, what we use mostly are generally we use dictionary or creating data frame from other data frame and reading data from variety of sources. These two are the mostly used, commonly used. We won't go for these options. Okay, but still yes. Fine. So any doubts on data frame creation, please ask. Otherwise, we'll move forward. Location of the file, have you, Neha, we discussed in the NumPy. I told you this NumPy, in NumPy, how to get the current path, how to get a current path. Those commands I told in the NumPy. It is taking this location, this we uploaded in this location, right? What is this location called? What is location, guys? What is this location? So when you use this anek, when you use this series, you don't pass the columns there only. Here in this exam, when you use the series, you are passing the columns here only, right? That's what it is giving you the null. You set separately columns. In the case of list of series, you don't pass the columns here. Columns you set separate, it works. Understand? It gives the error otherwise. See the JSON file I have, guys. This is my JSON file. I just generated myself. See, when I run a JSON, this is the output you are getting, right? 1012, 108 is the last record. It will take as a null or a nan. We will talk about the null value handling further. Prasanna, null value handling is the most important in the data cleaning process. Null value handling is the most important in the data handling, data science area. So we'll talk about null values. See, for example, maybe some of the student details are not provided, right? That happens in the practical scenarios, right? Some student has, for example, not selected the course, but we have other data. So when course is not selected, we can't set the fee also. So that can be null and null, right? That scenarios, yes. We have special module on handling data cleaning and handling null values. There are special methods on that. We'll talk that. Fine. So any questions pending still to answer? Purushottam, yours is clear. I've shown the JSON again. These three files, if you want, I'll put in the data set. Okay. So creating data frames. Clear, guys? And any doubts? All done? Okay, let's move to the next topic. Data frame attributes, most commonly used attributes, important attributes. Shape, ndim, size, dtype, columns. Already I shown the columns, right, for you. How to set the columns, how to get the columns. Same attribute we use. What are the values we have, indexes, all this you can get it. So let's start with, to understand these attributes, I have taken a two data frames here. See, one data frame, this is the, I am not passing any data here. What happens? df1, so none can be represented either with none, or you can also nan. None means no value provided. None means no value provided. Nan means not a number. Nan is a constant defined in the NumPy library, NP. If you want to use, you have to import this. Import NumPy as NP. Okay, I just shown the num also. Fine. So df1, I am creating empty data frame, guys. Just to understand these attributes, I created empty data frame. df1 is an empty data frame. Okay, and I created df2. df2 created with some data. And here I just taken the null values also. None and nan both. More on this we'll just see later. I have a two data frames, df1, df2. Can you tell me the shape of, what is the shape? Already we discussed this in the NumPy. Now we are talking about a shape, first attribute shape. Can you tell me the shape of, what is the shape? What is the shape, guys? What is the shape? df1 shape is df1 0 0, right? df2 df2 4 3 or 3 4. Some guys written 3 4, some guys written 4 3. You again you are writing 2 3, so half right, half wrong. Is a row column? Column row generally. Row column, guys. How many rows are there? 4 rows. Columns 3 only, right? Columns 3 only, right? Columns 3. Name column, age column, course column, columns 3. Rows. Rows means number of students, right? Srinivas, one student, VAS, one student, Hello, one student, Hi, one student. 4 students means 4 records are there, 4 by 3. So let's see the shape now. Shape represents number of rows and columns. It returns a tuple representing, rows and columns. Rows and columns. Tuple of rows and columns. So you already guessed it. See this now. Something is okay. It is showing a different number. Can you guess why it is showing a different number than what we expected? This basic simple question. Can you show why it is showing? Lakshmina, you're right. No. If you ran twice also, Alok, it is taking the df1, df2 here. This df1 which I read from my students.csv file. This df2 which I read from Excel, it is taking. Now I have to override that, right? I'm creating another df1 here, another df2 here, but I didn't run this cell. So the previous, if I run this, again it's freshly declares the variables. Let the run the cell. See, now we have, this is the empty data frame, first one, second data frame is created. Now you run this shape as empty data frame is 0 columns, empty data frame 0 columns, 0 rows, 0, 0. Second is 4 rows and 3 columns. Next, ndim. The ndim represents the number of dimensions. You tell me the dimensions now. Ndim gives you the dimension, the number of dimensions. df1 dimension tell me, df2 dimension tell me. What's the dimension of the data frame, guys? Data frame dimension. If you work on a series 1, data frame 2, df1 is a data frame, so always it is 2. Data frame, whether it contains the empty, means data frame contains rows and columns. So 2 dimension it is. It may have the 0 rows or 1,000 rows. It may have a 0 columns or a 10 columns. That is a shape. Number of rows and columns representing the shape. Data frame dimension is always the 2D. It's a 2D, 2. Size is simply number of elements. In the first data frame, we have a row 0, column 0. Size of number of elements in that 0 only. But the second data frame, 4 into 3, right? 4 rows, 3 columns. How many values are there totally? 12 values. 0 and 12. Next, dtypes. Returns the data type of each column. Data type of each column. Can you tell me the data type of each column? Name data type. Age data type. Course data type. Name is a string, right? So it is taking as object. Age is a float and course is an object. In the case of empty data frame, see, it is creating internally one empty series object. When you create empty data frame, it is internally creating one empty series object. That's it. No columns in that, so it's not showing anything. But second data frame, we have 3 columns. Each column data type we have. If you want, you can customize, guys. Maybe if you want to set the column data type as integer only, int64, you can say that. When you're using date type columns, yes, you can say date, you can say string explicitly. Generally, string means it will take as object, but you can represent as string. Column data types can be customized. We'll talk about that later. So currently what I'm doing is, I'm trying to see what are the data types of my columns in the data frame. I have a data frame 1, which is empty data frame, no columns, so we can't see any data types. Whereas data frame 2 has 3 columns. Okay, what are the data types of those columns? I want to see that. Yes, you can see the data types of columns using dtypes. Okay. Next, df1 dot columns. It gives you the list of column names. What are the columns we have? It will give it will return the index object. See this. For the first df1, nothing is there, so leave it. Second data frame df2, we have 3 columns, right? Name column, age column, course column, which is of type D type is object. It is creating index object. Already I told you guys, name is a column label, right? That is the index. Am I right? Your column will have name. These are the column names. Also, your column will have an index, right? 0 index, 1 index, 2 index. So these are the column names or labels, right? 0 is a column label. name is a column label. So these are either you call as a label, index, any term. It has two things, number based and name based. So columns gives you the list of columns available. So default they are considering as dtype as an object present. Next, df dot values. It gives you all the values of the data, all the values. See now, it is returning df dot values means list of list, guys. List of list. List of list. And list of list. Index gives you the index object, range index object. This we have only 0 records, right? Start 0, or you see this second one, DataFrame 2, which has a 4 records. So start 0, step 1, stop at 4. So what are the indexes you will get from this? What are the indexes you will get from this, guys? 0, 1, 2, 3. 3 also Purushottam. 3 also. 0, 1, 2. It won't go to stop, right? It won't go to stop. So we have 4 rows only, right? How many rows we have? 4 rows only. 4 rows indexes are these only. 4 rows indexes are this only. Step as a default step as a 1. This is internal, not required. We may not use index outside, but how the row indexing it shows internally. Based on the number of rows as a stop it is taking, default step as a 1. So whenever you access the rows using the row index, automatically it will give as 0, 1, 2, 3. So here important for us, values method, which gives the list of values, list of list. Next, columns gives you the index object, which gives you the all the column names. Fine. Dtypes gives you the data type of each column. Each column, if 20 columns are there, each column data type will show. Fine. And data types can be customized. The default, if it is string is there, person has asked if it is string, why it is taking as a string, maybe, right? So default is taking as a object only, guys. If you want to specifically change it to object, yes, you can. Age is actually given as in the default, it is taking all as a float only. But I want to say this as int only. I don't want to make it as a float. Int 64. These are the NumPy data types. np dot float 64, np dot int 64, np dot object. Okay, so you can change it. We'll understand that further. So these attributes clear. DataFrame attributes clear. Quick revision of DataFrame attributes here. Shape gives you the number of rows and columns. ndim gives you the dimension. There is a 1 dimension series, 2 dimension. DataFrame always 2 dimension. Size gives you number of elements. dtype gives you data type of each column. Columns gives you list of columns as an index object. Values gives you all the values, rows and columns using list of list. Index gives you index object, which represents start point, stop point, and step point. Right? So we use this at many places further. These are attributes of DataFrame. Next, most important, guys, descriptive methods in Pandas. These are built-in methods, gives you quick summary or a preview of your database. So previously I have shown you there are various ways to create DataFrame, but in the real world applications, if you are working in any project, you won't use those approaches. You will use only loading data from data file, loading data from a data set. We will take some data set file, first load it. You load the data into DataFrame. From suppose you have a CSV file, guys, CSV file which has 20 columns and 10,000 records. So you just simply say first step always is load the CSV. Then all the data from CSV will be copied into DataFrame. Now you need a quick preview of your data frame. In any scenario, you will call these methods first. This is most useful for EDA, exploratory data analysis. EDA stands for exploratory data analysis. And important methods: head, tail, info, describe, value counts. Most important. Always we use this. I'll just show you 1 minute. I think I have some project done somewhere. So later I'll give you an assignment, a big assignment on this data frame, Pandas. So that will be like this. It will come like this. I'll give you like this. See, normally first we do imports, right? Then load the data. So I have a employee data.csv file, pd.read CSV. I got it. Then check the first few entries. To understand what are the entries are there, you just call a head method. It gives you top 5 records. Top 5 records. And you see the shape of that. See, we use this always, guys. First, you inspect the data set. You are inspecting data set to see shape. Means what shape is giving, guys? It tells you loaded data frame. You can't open the CSV file and see how many rows are there, how many columns are there. It is immaterial for you. Just load into data frame. Inspect it. Shape gives you, it has 74,160 records, 24 columns. There is info method, I just commented. And then we do basic statistics using the describe method. And you see about column and data types. Each column data type you will get it. See, all 24 columns data type. Then we'll start the data cleaning. I'll give assignment like this. Each task will have marks for you. Suppose the first task is, I think you're done with the data frame first task. What's the first task in the data frame, guys? Data understanding. In data understanding, first you load the data pandas library. Along with that, NumPy always you need. Why NumPy you need? You may call some NumPy related libraries. Then load the data. Then check these basic tasks. All this you do. Okay, guys. Handling missing values, that we'll talk later. So leave this. So just I shown how the real project you do it. Now come back to this. So these are the, I think these are all I shown here. Value counts also we use thoroughly. So let's start. I have a big data frame. Data I've taken some 8 records here, guys. Okay. Now create a data frame. Dictionary only I used. Dictionary. Generally we do the file reading. So yes. Okay, I have my data ready. Head method first. Head returns the first n rows of the data frame. Default goes to 5. After loading your data from a file into the data frame, your first task is see the few records, how the data looks like. You to get an idea. So you just say head. It gives you 5 records. See, I'm seeing you first 5 records. You understand glance. If you want to see only 3 records or 10 records, you pass head of 3. Head of 3 gives you 3 records only. If it's a head of 6, gives you 6 records. So head default takes the number 5, not passing anything, or you want to pass anything, you just pass it. Head method clear. It shows all the columns and the number of rows. Is the filtering number of rows only. First n records will be shown. Columns, all the columns will be shown. If you see my data frame here, guys, I have a student ID, name, age, course, city, fee. The other various columns I have in 1, 2, 3, 6 columns are there. All columns and number of rows. Tail returns the last n rows of data frame. Last n rows. So if you say data frame, how many records I have? 0 to 7. Last 5 means 3, 4, 5, 6, 7. Even though if you have 1 million records, we can't load 1 million records into this. It will, your collab or whatever editor you are using that time, it will collapse. This is to see the glance. Just see whatever 1,000 you have 1 million records, immediate number. First 5 or 10 I want to have a look. Last 5 and 10 I want to have a look. Use that. Clear? Last 5 or last 2 records. I just want to see. This only to get a overview of how data looks. How data looks. Just to see how data looks. Okay. Why it is, we will understand. Once we start a project, you will understand why this is required. Next, info method. Most important, guys. Info method gives you just call info like this. df.info. Enough. Simple. It gives lots of data for you. You call it df.info like this. It gives you number of rows and columns. There's a shape also included. Column names it will give, and null, not null count, non-null or not null count means in each column how many non-null values, means values are there. If nulls are there, it counts the values. Data of each column and memory usage. How much memory used for this data frame or for a column. Have a look in the info. See the shape is displayed or not, guys? Shape is displayed or not? There is index number of entries. How many records in this data frame? 8 entries. Indexing from 0 to 7. It is giving a range index object. We have seen that range index object. 8 entries. Start 0. Stop 8. Step 1. Data columns. How many columns? Total 6 columns are there. Now see, guys. 0 first column. Student ID. In this, how many non-null values are there? 8 non-null values are there. What is the data type of this? Int 64. Second name, 8 non-null values. Object type, age, int 64. Course, object, city, object, fee, int 64. Data types, we have 3 int 64 types are there and object types are there. Memory usage, total data frame with these 8 records, it has occupied 516 bytes of data. You got the glance, right? In this, how many records are there? How many columns are there? Each column name, data type, totally how many integer types are there? How many object types are there? How many string types are there? How many date types are there? All you can get information here. Every data frame when you create, first you have to see that information about this is one we call always. I shown you the real project scenario, right? Info is clear? Done. Describe. This also this gives you descriptive statistics for a numerical columns. The columns you have are of 2 types, guys. The columns you have always of 2 types. Numerical columns, and categorical columns. Columns of data frame can be divided into 2 types. 2 types of columns. Numerical columns, categorical columns. Tell me, numerical columns means? Int float, right? Int float. Very good. Int float. Categorical, any object type. majorly the string types and date type. String date. Date also. Hello, Ankit. So in a table, in your data table or data frame here, other than int, float, string, date, what other types of columns you will take, guys? Object is a common term. Specific string, date, boolean. You may have a booleans also. Other than that, what you will take? This is a real world data. You are taking the real world data. Data you are storing maybe in your SQL database or NoSQL database. You are fetching it. Image binary formats we may not use. Yes, maybe you can use, but our data analysis, very rare case of that. Most commonly these, right? Strings and dates, you can call them as categorical columns, and int float are called as numerical columns. So why we came to this point here now is, whenever you call a describe, which gives you the descriptive statistics, but by default, it gives you descriptive statistics of numerical columns only. How many numerical columns are there in this table, in this data frame? How many numerical columns are there, guys? How many numerical columns are there? What are they? Student ID, age, fee. It is showing here, the info is here only. See, there are 3 numerical columns and 3 categorical columns. Am I right? 3 numerical columns, 3 categorical columns. Already our info we got from info method. So it shows if you want to display if you want to generate the descriptive statistics for all the columns, yes, you can do that. But by default, describe method only displays the statistics for a numerical columns. Let's see, what are the descriptive statistics? Count. How many values are there? Mean, standard deviation, STD, min, max. Min is the lowest value. Max is the highest value. Median. It will calculate for the median value. 25%, 75%. These are the values it shows. Let's have a look. You say describe, df.describe simply. If you say df.describe, it shows only the numerical column related descriptive statistics. You can say df.describe include equals to all. It includes all the columns, including object type also. Let's have a look. You will get a clarity. First, we printed the df.describe only, right? Numerical. See, it is showing only about numerical, guys. What are the numerical? How many? We discussed 3. Student ID, age, and fee. Student ID, count 8. Can you tell me? Age, count 8. Fee, count 8. What is this count 8? Not the rows. Not the rows. Values. See, row is including all columns, right? Row is nothing but all the columns, guys. I am asking about the student ID only, age only, fee only. How many values in the student ID column? Currently, there is no null for us. That's what 8 values are there. It's just okay. Let's have update the data frame little bit. Come here, we'll have that count also. So what I'll do now is student ID 108. Okay, name also let it be. Name also keep it. Age also keep it. Student ID 108 has not specified. You can say none. Course name not selected, guys. So that fee also not there. np.nan. I'm using nan, np.nan. That's what I need to import numpy, guys. Import numpy as np. Okay. And so these two guys somewhere, this guy is not showing city. This guy is not disclosing city. np.nan. Student ID. Okay. This guy is not disclosing the age. I don't know why. Student ID. How many values are there? 8 values. Name 8 values. But age has 7 values only. Course has 6 values only. City has 6 values. And this has 7 values. So I think you understand a count. That this is giving you indirectly whether null values are there or more nulls are there or less nulls are there. I'll show you this again. Info again I'm running, see guys. No, I think I modified that. I have to rerun this data frame, recreate this data frame. So run this cell again. So data is reflected now here, guys. See, none is there, none is there, none is there somewhere. Info again I'm running. See, you see here only we have the information, guys. And your statistics changed here, you see. None means no value provided. More or less, both are same only. Purushottam, none means the actual is none means no value provided, right? No value provided. Okay. None means not a number. Not a number. Okay. So whenever I use the nan or nan there, it is taking automatically as a float here. Otherwise, it is as a default int only. There is a Shivsagar, I am telling. Categorical 3 only there. See, categorical 3, object types 3 only, no change. But previously we got a 3 integers. But now 1 integer showing, and because the change you see here. Whenever nan value is there for any column, nan is there for any column. I'll show you here. Okay. See, age containing the nan, right? Age containing the nan, and phi containing the nan. Have you seen this? A phi column containing the nan. So this is selecting as a float. A is containing the nan here, picking as a float. Student ID, all numbers, cool, integer only. 1 integer, 2 float, 3 object type columns are there. City, but object it is. Object means object. It won't take as a float. It can't take as a float, Santosh. It is an object, right? So object. Common object. Name as an object. Course as an object. Number types, whether to consider as int or float. Student ID considered as int only. But age considered as a float. Phi considered as a float. So I hope this is clear. Okay, back now. Info is clear, right? And see, info changes. Total entry is 8 only. Fine, 8 records are there, right? Student ID, how many non-null values are there? Non-null count. 8 non-null. Means all records having the ID and name. But age 7 non-null only. It means null values are there in that. Am I right? And 7 only, 6 only, 7 only. And also this will reflect in the describe method. Rerun the describe again. For numerical columns, see guys, there are fee, student ID 8, age 7 values only, count 7 only, value 7 only there. Mean of that, mean is 104, 32, and standard deviation is ready. Minimum value 101, maximum is this. Generally, for student ID, this is not required. For age related, maybe you need that. What is the mean of this? What is the mean age, max age? What is the mean fee, max fee? What is the mean fee? These statistical values, we need it. Okay. Generally, these kind of statistics are useful only in the numerical values, not useful for the categorical values. Okay. But still, if you want to see that, you can see. See, guys, for the name, what minimum it will calculate, guys? What minimum it will calculate? Name case means what is the maximum? What is standard deviation? These all for not for a categorical. These statistical calculations like a mean, STD, min, max, 25%, 75%, 50%. Why these percentages? You will understand on the way. These are generally no use with the categorical columns. We won't do this actually. We won't see also, unnecessary also. Generally, when you load a data frame, when you create data frame by loading data from a file, we do describe without all. So that only numerical columns related statistics you will get it. What is use of this? How? This is the information you're getting. This information helps you to pick, to do something further analysis. Okay? Percentages, guys, percentage. Max means 100%, right? Min means 0%. 50% of the fee, right? See, minimum fee 15,000, guys. Maximum fees 25%, 20,000. What 50% of the fee means? 70%, and 50% means min plus max by 2. 20%. How this statistics will be used it when we do analysis, we will understand it. This is a basic thing. Percentages means maximum value is this, guys. 70% means this, 50% means 20% means min means 0%. 100 min means 0% actually. Maximum 100%. These statistical values will be useful for analyzing data. How this will be useful, we'll understand it later. Alok, it is not changing to object, it is changing to float. If you see this, there are 3 objects. In object array type, if you keep a none array, nan, whatever, object only. Like a name is there, course is there, city is there, these 3 are always objects. Even we have the nan, none, whatever. But numerical columns can be of 2 types, guys. Numerical columns can be of 2 types. One is int, second is float. Here, int student ID is the int. Student ID is the int. You see here, student ID is the int because it has all the values. Age integer only, but why considered as a float? Because we have a nan in this. Fee is a actual integer numbers only. Previously it has shown as integer only, 3 integer only, but now it is showing as a float because it has a nan value. Categorical columns always object type. So describe is clear, guys. Describe is done. Next, value count. So age, how many values are there? Df of, this is a syntax to access. Till now we didn't use this. So after creating data frame, I want to access a specific column, guys. Df. Just before this. You want to access the age column values, guys. You can just write simply like this. It gives only the age column values, which is of type float. So one nan is there and this. How to access specific column? Like this is syntax to use. But more further, I'll show this. That's what I didn't show this here. Let it be. So df of age. This is referring age column dot value counts. In this age column, how many values are there? I'm asking that. How many are there, guys? Age column. Next, city. Df of city dot value count. Df of course dot value count. Value count is kind of occurrence, am I right? In age, 30 two times came. 35 two times came. 25 one time. 45 one time. 28 one time. This is giving name column related data type integer. City, Bangalore, 3 times. Chennai, 1 time. Hyderabad. Courses, ML, 4 guys joined. DL, 2 guys. Python, occurrence 1 time. Do you understand the value count? This is also most important, guys. Okay. So the descriptive methods, we have done it. Head, tail, info. Tail, we may not use it, but they given it. You can have a look. First, whenever you load data frame in the EDA process, in the data analysis process, first you load the data from a file into data frame. Then have a look in the top 5 records, 10 records. Then see the information, which gives you how many columns are there, what data types are there, what are numerical columns, what are categorical columns. Everything you will get it. See the describe, see the statistics for numerical columns. This we will use in a different use case, but we will use it. These 5 are the most important descriptive methods of. Okay. So that's about this. Describe is done. Value count is done. Yeah, we have a sum, min, max, all are there. Those I will cover under a different section. Yes, you can do that. I kept that under a different heading actually. Not course. Course we can't use sum because it is not a, I'll use a fee. Total fee is 1,38,000. Already we got the min value here, right? In the statistics we got a min value. Min is there. Min is there, max is there, mean is there, median is there. Yes, all methods are there. That I'm going to cover you in different section, guys. Suppose you want a min, fee minimum value is 15,000. You want a max 25,000. Median is there, mode also there, mode that well, we need to understand that separate. Okay. Fine, guys. So next is very important, selecting rows and columns. Indexing and slicing the data frame is most important. We have 3 sections for this. This we will understand in the next session.